Now stop angry, keep it real hot. Give me the knee, rip the touch. So don't make me wait. Fuck around and I'm gonna bite you. Snatch my leg. I can flip that flow. I can stick that hoe. I can get that dough. Throw it with that chick. Ain't a thing about this shit I can't do. I haven't seen. But when it gets dark, it's like a nigga's having dreams. All like this.
All right, that's enough of that. So, anyway, y'all need to stop being greedy. I'm going to show you why. Actually, John Reagan, Board Brains, Alshay AI. I am tired but excited and ecstatic. And let me get this out of your way because you don't need to look at OBS. Oops. Um, yeah. So you can see up here currently the finished versions of the JARVITS Core v9. This is our Pascal-Chimera version 9, which is obviously two versions past the ones that I've released, which is version 7. So it does take a lot from version 7, it adds some additional things, and I'm going to show you a little bit of the training as well as the size and some of the build data, as you might put it. So, excuse me, I'm really tired. I was up to like 3, 4 this morning with this going, and we got a little bit more left to do before it's what I would call usable. I mean, it can be used now, but as you can see over here in the folder, these are the various models that went through each stage. This is showing at 136 megabytes of RAM on disk per model stage. And that's actually really good. And yes, it is accurate. Um, Essentially, the Pascal-Chimera V9 is a modular AI system. It does not need to start out large. It just needs to start out and get a good foundation, and then we're able to expand the layers by adding new trained layers or training new layers. And the routing system, the way it's designed, it allows us to basically just slot them in like Legos and it make the connections. It's actually really, really trick. Really trick stuff. Um, so yeah, additionally, that router allows us to swap out for a quantum switch that allows us to deal with semantic ambiguity a lot better. So, for example, a word that has similar meanings but within different contexts, or similar, same word but different meanings within different contexts. The way that works is it actually, because of the surrounding components, when it goes into the quantum switch, it actually delineates out the part that's not associated and maintains the one that is. So we get a really high accuracy rate on those things, and we can put them back into the AI system and keep processing. So JARVITS models, JARVITS is my model. I'm building a different one that will be kind of more of a standard blank for all of you called Alshay. You'll be able to name it whatever you want. It's just an Alshay model, but it'll take whatever name you give it. It'll remember it. It'll use it as its identity. So you basically get your own AI model that you get to build up, and as you do stuff with it, it'll grow and develop with you. Um, but let's see why that works. So, like I said, as you can see here, it's the models are pretty small, and it'll grow as it interacts, and we put some more stuff in it. So, just for example, I don't even need to train a lot. Oh, the camera went off. Oh well. I don't know what's wrong with that thing right now. Let's see. So you can see here we have the 149, the epoch complete. Our average reconstruction loss is nice and low. Our average vectoring loss is nice and low. Our encoder anxiety dropped nicely, and our generative anxiety dropped really nicely too. So we're actually able to take in as well as put out stuff without shaking up the model too much, without it having to work too much. Additionally, here you'll see the cognitive knobs, as we call them, the alphas. So these are self-setting dials, you might say, as to how the model uses the different layers and the different construction of the layers in order to process certain things. Okay. Um, it automatically adjusts these. These actually start out at 0.5. They start out flat and flatline, and it adjusts them accordingly based on its training materials. So, additionally, this model is multimodal, so it sees in Gaussian Splat rendering, and it also hears in Gaussian Splats, and that's all set up, ready to go. Over here, for just some reference, you can see I ran the NVIDIA SMI. You can see I was spanning across both cards. GT or the RTX 3090s. 90 was like a high point, really. But even more importantly, during the full training session, I was only using a collective 3 gigabytes of RAM. Okay, these models up here are they're either 380 or 440. I can't remember, but million parameters. Okay, so when it comes to training them, I don't actually have to train the whole model all at once across everything. Because of the modularity of the system, I can actually train each individual component up to its, we'll call it standard of competency, and then put it together, essentially. So this is working out really well. The next phase is to set up the speech therapy and stuff, and then I'll be able to give you guys some demonstrations, and I have some other tests I have to do. I have to check the grouping on the model and make sure that all of this stuff, even though it looks really nice and how it all came in, make sure that it did appropriately hub things. But everything I've seen so far, I'm not even worried about that. Yeah, so on phase 9 right here, I don't actually have the phase 9 data set ready yet. It's a whole other thing of stuff. So I'll be putting that in and having it train on that. And then there's a couple other phases, speech phase and stuff. And then, yeah, then it should be ready for me to finish testing once I validate it, verify that it works appropriately, correctly. I'll convert the weights and put them into the PolyMorphOS. And so right now, because of how all that is working out and how the O1 memory allocator works and JARVITS working at that level, I expect it to be just incredibly fast. Even with inference, it shouldn't. I mean, it's maximizing clock cycles essentially across the whole OS and how JARVITS works within the OS. So it's just crazy, crazy fast. I think that's it for now. I gotta get back to working on this stuff and finish the training, do some verification testing that I've set up to run, make sure everything works right, and then yeah, get these models going. So that's interesting because that means like all together with the AI initial AI package, it looks like the OS is probably gonna end up being somewhere between say like 175. I mean, high end maybe 300 megabytes altogether with the AI in it. So, man, that's scary. You'll have fun and go make some stuff.